This brings us to the issue of analyzing the contact pattern. Let's first look at an ideal contact pattern. This contact pattern is from a tooth without load. The length and position are important. Here we see that the contact is covering approximately 30 to 40% of the tooth surface and is located central to the toe. This would be an acceptable pattern of a gear set without load. But what if the pattern is not correct? Here is an example of a pattern without load that is not located central to the toe. With this pattern, the gear will most likely not function properly and it could fail in operation. In theory, the contact pattern should be elliptical in shape. However, it's important to keep in mind that the shape of the contact pattern is not as important as its location. When assessing the contact pattern, it's important to look at both the concave and convex sides of the gear and pinion. For the most part, the pattern on both sides of the teeth should be the same. If you find that the contact pattern is incorrect, most likely the pattern will be wrong on both sides. This can occur due to three main errors. These are profile error, cross contact, and shaft angle error. Let's look at each of these three problems. Profile error occurs when the mounting distance is incorrect. This is the most common type of error and is the easiest to correct. First, we see the condition where the gear has high toe contact on the convex side and high heel contact on the concave side. Also, the pinion has low heel contact on the convex side and low toe contact on the concave side. To correct this, the mounting distance must be decreased. In this example, the gear's convex side has low heel contact and the concave side has low toe contact. As for the pinion, the convex side has high toe contact and the concave side has high heel contact. For this condition, the mounting distance must be increased. For both types of profile error, altering the mounting distance is accomplished through the use of shims. In this illustration, we can see the location of the shims which are used to alter the mounting distance. The condition of cross contact occurs when the pinion is either too high or too low in relation to the gear. Here we see the contact patterns when the pinion is too high. The convex side of the gear has heel contact and the concave side has toe contact. Corresponding contact errors are also found on the pinion. To correct this, the pinion would need to be moved down. If the pinion is too low, the convex side of the gear has toe contact and the concave side has heel contact. Again, corresponding contact errors are also found on the pinion. To correct this error, the pinion would need to be moved up. Be sure to note that correcting this problem by moving the pinion up or down is usually not possible without modifications to the gearbox housing. The third condition is shaft angle error. This is caused by incorrect shaft orientation of the gear and pinion. Here on the gear and pinion, we see toe contact on both the convex and concave sides. To correct this error, the shaft angle must be decreased. On the other hand, if heel contact is present on the convex and concave sides of both gear and pinion, the shaft angle must be increased. However, correcting this problem by moving the shaft angle also requires modifications to the gearbox housing. When reviewing the contact pattern, a condition to look closely for is called hard line. A contact pattern with a hard line would look like this. Instead of an elliptical shape, the bottom of the pattern ends abruptly in a hard line. This condition would indicate that the gears are not making correct contact and are causing an area of high stress. This area of high stress can cause pitting and subsequently failure of the gear. So be sure to watch for this condition and take corrective actions. For a more detailed explanation of interpreting contact pattern, please consult page 18 of our stock gear catalog, which is available in print on our website. Of course, if you require more information on adjusting the contact pattern, please contact Arrow's Design Engineering Department. Once you're done with the Prussian blue marking compound, it will have to be removed with a solvent such as lacquer thinner or as directed by the manufacturer. There is another issue to keep in mind when assessing the contact pattern. When the gears are under load, the contact pattern will be different than when there is no load. The area of contact will expand on the surface of the tooth. If you need to check the pattern under load, the following method can be used. First, obtain some layout bluing. This is material similar to a thin paint, and it is available from most industrial supply distributors. This layout bluing can be either sprayed or brushed onto the tooth surface. After running the gears under load with lubrication, the contact pattern under load will be visible. If you find the contact pattern is not acceptable under load, it may be required to make adjustments to the gears in the no-load condition. Again, if you need assistance with any aspect of interpreting contact pattern, please contact Arrow Gear's Design Engineering Department. In this program, we've presented an overview of the key parameters required for proper installation of bevel gears. By following the procedures, your gear sets should run optimally and perform trouble-free during their service life. We hope that you have found this information on the installation of bevel gears to be helpful. If you have additional questions, please feel free to contact Arrow Gear's Design Engineering Department at 630-969-7640, extension 255.